In this video, we're going to discuss how to evaluate logarithms. In particular, we're going to do this by using the exponential form of the logarithmic expression in order to evaluate it. Evaluating logarithms is an essential skill when working with exponential and logarithmic functions. And in order to evaluate a logarithm, the typical approach will be to convert the logarithmic statement to exponential form and use our previous knowledge about exponents and how they work. For example, let's say we wanted to evaluate log base 2 of 8. In order to do this, we just remember what this means. It means that we're looking for some number, which I might call y, and the y is the number that I raise 2 to that power to get 8. So log base 2 of 8 equals y will convert to 2 to the y equals 8 in exponential form. And now thinking about powers of 2, we quickly see that 2 cubed, 2 to the third power, is equal to 8. And therefore, our value of y is equal to 3. And so from this, we can conclude that log base 2 of 8 is equal to 3. It's the exponent that 2 is raised to in order to get the number 8. To see another example, let us consider the logarithm base 2/3, so a fractional base, of the number 4/9. And we can approach it in much the same way. We could set it equal to some number y, and then convert this to logarithmic form. In logarithmic form, we see that this would convert to 2/3 raised to the y power equals 4/9. Although it might be a little bit more thinking than the first one to see this, it hopefully is pretty quickly, or can be seen pretty quickly, that 2/3 squared would be equal to 4/9. Okay, 2/3 times 2/3 would be 2 times 2, which is 4, over 3 times 3, which is 9. And so here we get that y is equal to 2, and in particular, that means the log base 2/3 of 4/9, which is equal to y, is also equal to 2. And so in both of these cases, we easily evaluated these logarithms by converting to exponential form and using knowledge of exponents to find the value. So let's take a look at a couple more formal examples. Here we're given an equation, y equals log base 4 of 64, and asked to solve the equation. In other words, we want to find the value of y that makes this equation true. In order to do this, we approach it just like we did before with when we evaluated the logarithms on the previous slide, and we're going to convert this equation to one in exponential form. When we do that, we get 4, the base, raised to the value of the logarithm, which is y, equaling 64. So we need to solve the equation 4 to the y equals 64. So we have to ask ourselves, to what power do we raise 4 to get 64? And we quickly should be able to deduce that 4 to the third power is equal to 64. And therefore, our value for y, which is log base 4 of 64, is equal to 3. 3 is the exponent that we would raise 4 to in order to get 64. So the log base 4 of 64 is equal to 3. For another example, let's evaluate y equals log base 3 of the fraction 1 over 27. Like in the previous example, we're going to get started by converting it to exponential form. So we take our base 3, raise it to the value of the logarithm, which is y, and set that equal to our number 1 over 27. And so we need to determine a value for y for which 3 to the y power is 1 over 27. Okay. Now, we know that 3 cubed is equal to 27. But this doesn't exactly help us directly because we don't want 3 to the y to be 27. We want it to be negative 27. However, we should also remember that one property of exponents is that if an exponent is negative, it will move that number to the denominator. And so we might then try 3 to the negative third power. 3 to the negative third power To evaluate the negative part first would be 1 over 3 to the positive third power. So 1 over 3 cubed, and 3 cubed is 27. So we see here that 3 to the negative third power is 1 over 27. And so this tells us that log base 3 of 1 over 27 is going to equal negative 3. If you'd like some additional practice, try to evaluate the following two logarithms. Y equals log base 121 of 11, and y equals log base 2 of 1 over 32. You can go ahead and pause the video if you'd like and try these on your own, and unpause to see the answers in just a few seconds.